Today I'd like to talk about selecting a motor to use with one of our phase converter panels and some common troubleshooting items that I've seen people run into. So when selecting a motor, you want to find a motor that can be wired into a 230 volt wiring configuration that is a 3-phase motor, and you're looking for a motor that can be a 1700 RPM or 3600 RPM. And that RPM doesn't need to be exact, but it needs to be within probably 50 to 100 RPM of those ranges. Within wiring a motor, you can get some common wiring configurations. They can come in 3 lead, 6 lead, 9 lead, and 12 lead motors. This motor that we have here is a 9 lead motor, and when we go to wire it, you'll see that it has labels naming the wires. So when you're looking for a motor, you really want to make sure that these labels on the wires are well identified, that you can read them, because if you don't know how to pair them, the motor becomes basically useless, and it's very hard to find out what number's what. So it's always good to have well labeled motor leads, and it's just a time saver to make sure it gets wired properly. Typically there's a data plate on the motor that gives high voltage and low voltage wiring pairing configurations for the motor. You're going to try to find that data on the motor, and you're going to want to again search for the low voltage 230 volt wiring configuration for the run situation. So within this, you'll see that there are, in this particular diagram, dots with lines connecting them, and you'll see that 1 and 7 is connected, 2 and 8, 3 and 9, 4, 5, and 6 that just gets paired together and tied. So when connecting the motor to power, once we pair these, we can then hook these up and tie into the phase converter panel, the other side of this wire. And it doesn't matter what color goes to what, as far as like 1, 2, and 3, but we can look at these and connect them up. So then we're going to want to ground to the case. The next thing we're going to want to do is evaluate the condition of the motor. One thing we're going to want to do is make sure that the motor spins freely. If the motor spins freely, we want to listen to the bearings to see if the bearings are bad. You might need to replace the bearings, and then the windings are still good. That could still be a great motor. It just needs a little work put into it to make a great phase converter idler motor. The next thing we're going to check is we want to check the windings, and there's 2 checks on the windings that we want to do. First of all, we're going to check each lead to ground to see if the windings are grounded out, and that's going to be a continuity test. And we're going to basically take these 3 leads that would go to our panel that would be the supply power to the motor, and we're just going to check that lead to ground. Do each of those. So to check our continuity to ground, we're going to grab our meter, and usually the continuity test is one that's an audible test and usually has a little sound wave form on the meter. And if you take your leads and you touch them together, it's usually an audible sound that if you hear the sound, there's continuity. So within this test, we don't want continuity to ground. So we're looking for it to not make noise, but we're going to take our 3 leads, and we're gonna make them all flying leads here so they aren't touching anything else. Make sure they're not touching each other. We're going to grab each one and check continuity to ground. So we're just going to ground to the case, and we're looking for no sound. So right now that one is good, that lead's good, that one is good, and this lead is good. So we don't hear any sound, that's what we want. Again, so right now it is not grounded out, but there could be a case where the windings are like a wire is sort of broken but still within the insulation, so it would have higher resistance. And the motor might still work, but it might get hot. So to check this, we want to check resistance from one lead to the next, which would be one of the windings. So to do that, usually we are going to put it in the ohm setting, and this meter just needs to have it selected from continuity to ohm, so we'll just hit the select button. We're in ohm setting here, and it's auto detect. And what we're checking here is to get a value that is the same across all three. So typically these change as we go, but you want it to settle down, and it's roughly 0.6 right now between that one. So we'll do another wire combination, and we'll check that one. And that one's 0.6 also. And then we'll check the final third wiring configuration, and that one is 0.6. So all three of those are equal, so that basically shows that the windings seem to be good. And if it was bad, you would see those not match. You would get unequal values there. So that's what we'd look for. So this motor's windings are good, and it's labeled well. It sounds really good. So this could be a great motor to make into idler motor.